If you thought the latest images from the James Webb Space Telescope were impressive, what you're about to hear will completely change how you see the universe. A new space telescope has quietly begun sending back images so vast, so detailed, and so revealing that even astronomers admit they were unprepared for what they show. The Euclid Space Telescope has released its first light images, and they don't just display beautiful galaxies. They expose structures we barely understand, patterns shaped by invisible forces, and a universe far more complex and unsettling than we expected. Tonight, I'll walk you through what Euclid has captured, why scientists are calling these images revolutionary, and why some of them become genuinely disturbing once you understand what you're looking at. Stay with me until the end, because this is only the beginning of what Euclid is about to reveal. Euclid is not a typical space telescope. It was never designed to zoom in on a single nebula or focus on one spectacular galaxy. Its mission is far more ambitious. Launched by the European Space Agency in July 2023 and positioned 1.5 million kilometers away at the Lagrange 2 point, Euclid was built to map the universe on an unprecedented scale. Its ultra-wide field of view allows it to capture enormous portions of the sky in a single observation while still maintaining remarkable resolution. This means it can resolve individual galaxies while revealing how millions of them connect into vast cosmic structures. What makes this unsettling is that Euclid is not just mapping light. It is mapping the influence of dark matter itself through subtle distortions in galaxy shapes caused by gravitational lensing. In effect, Euclid is revealing the skeleton of the universe, a structure shaped by something we cannot see and still do not fully understand. When Euclid sent back its first large mosaic of the southern sky, scientists were stunned by the sheer scale. In a relatively short observing period, the telescope captured hundreds of images covering an area of sky hundreds of times larger than the full moon. When stitched together, these images revealed millions of stars and galaxies, and yet this represents only about 1% of the final map Euclid is expected to create. That realization alone is unsettling. What we're seeing is not a finished picture, but a tiny fragment of something incomprehensibly larger. Researchers can zoom from enormous cosmic structures down to individual galaxies without losing clarity, revealing how matter is organized across vast distances. This is not just a photograph. It is a preview of the largest and most detailed three-dimensional map of the universe humanity has ever attempted. One of the most striking revelations from Euclid's first images comes from the Perseus cluster, located about 240 million light-years away. The image contains over 1,000 known galaxies along with more than 100,000 distant background galaxies. But the real surprise appeared when scientists examined the data more closely. Euclid identified hundreds of previously unknown dwarf galaxies hidden within the cluster, objects so faint they had escaped detection until now. This matters because dwarf galaxies are extremely sensitive to dark matter. Their shapes and motions act as tracers, revealing where unseen mass is concentrated. The fact that so many of these galaxies were invisible until Euclid suggests that dark matter's influence may be far more intricate than we assumed. The universe doesn't merely contain dark matter. It appears to be built around it. Euclid's images aren't just reshaping our understanding of large-scale structure. They are also exposing unexpected complexity at smaller scales. In galaxies like NGC 6822, Euclid revealed low metallicity stars that resemble conditions from the early universe, offering insight into how galaxies evolved billions of years ago. In globular clusters such as NGC 6397, Euclid resolved faint stars in the outskirts that were previously lost in the glare of brighter ones, unlocking new clues about the Milky Way's history. In regions like the Horsehead Nebula, its sensitivity uncovered evidence of free-floating planets and Jupiter mass objects drifting through space without stars, suggesting that rogue planets may be far more common than anyone imagined. Together, these images paint a picture of a universe that is not calm or orderly, but crowded, dynamic, and constantly reshaped by invisible forces. As more data emerged, a pattern became impossible to ignore. Galaxies are not scattered randomly through space. They are arranged along enormous filaments, cosmic threads stretching across hundreds of millions of light-years and intersecting at dense nodes where galaxy clusters form. Euclid's images make this structure unmistakable. The universe begins to resemble a vast cosmic web, with matter flowing along invisible pathways shaped almost entirely by dark matter. The unsettling part isn't just that these filaments exist. It's that their scale dominates everything. Every galaxy, every cluster, and every apparent void is trapped within this structure, guided by forces we still cannot directly observe. Euclid's precision in measuring gravitational lensing adds another layer of unease. By detecting tiny distortions in the shapes of distant galaxies, the telescope effectively reveals where dark matter is hiding. These distortions are subtle, almost imperceptible on their own, but when mapped across millions of galaxies, a clear picture emerges. Massive regions of dark matter bend space itself, warping the light of objects behind them. What makes this unsettling is that these structures are completely invisible. They emit no light, yet they outweigh everything we can see. Euclid is showing us a universe where the dominant form of matter is something we cannot interact with directly, something that silently controls the motion and fate of entire galaxies. Some of the galaxies captured in Euclid's first images are more than 10 billion light-years away, meaning their light began its journey when the universe was still young. By observing ancient galaxies alongside much closer ones in the same frame, scientists can track how cosmic structure evolved across most of the universe's history. Early analysis suggests that large-scale structure may have formed earlier and more efficiently than expected. Galaxies clustered faster. Dark matter organized itself sooner. This challenges existing models and raises uncomfortable questions about whether our understanding of gravity and cosmic evolution is complete. Perhaps the most unsettling fact is that all of this comes from only about 1% of Euclid's planned survey. Over the next several years, the telescope will continue scanning the sky, filling in gaps and sharpening structures. If the universe looks this complex at 1%, the full picture may be overwhelming. Euclid is not just collecting images. It is building a dataset so vast that it may force fundamental changes in cosmology, from the nature of dark matter and dark energy to the laws governing the expansion of the universe itself. Euclid is also revealing something strange about where galaxies are not. Vast cosmic voids stretch across hundreds of millions of light-years, appearing nearly empty. But these voids are not truly empty. They are shaped and defined by the same invisible forces that build galaxy clusters. The distribution of galaxies around them suggests that dark energy may be actively pushing matter apart, accelerating the expansion of space. These regions feel less like gaps and more like pressure zones, places where the universe itself is being stretched. As Euclid's datasets grow, scientists are facing a new challenge. The sheer scale of the information is overwhelming. We are no longer dealing with millions of objects, but billions of galaxies mapped in 3 dimensions. Patterns at this scale are too large for human intuition alone. Increasingly, researchers rely on advanced algorithms and artificial intelligence to interpret what Euclid observes. In a strange way, our understanding of the universe is becoming dependent on machines interpreting data beyond direct human comprehension. The most unsettling implication of Euclid's early images may be what they reveal about the limits of our knowledge. Dark matter, dark energy, gravitational lensing, accelerated expansion. These phenomena dominate the universe, yet they are explained by theories filled with gaps. Euclid exposes just how much of our cosmic model rests on unknowns. We can map the effects with extraordinary precision, but we still don't know the true nature of the forces behind them. At first glance, Euclid's images are breathtaking. Galaxies glow, nebulae swirl, and star clusters sparkle with near-perfect balance. But the longer you look, the more unsettling they become. This beauty is not comfort. It is evidence of relentless order. Gravity never rests. Dark matter never loosens its grip. Expansion never slows. What appears calm is actually the signature of a universe constantly pulling, bending, and stretching everything within it.